Good afternoon. I'd like to welcome you to the webinar on fractions, developing concepts and symbolism. This afternoon we will be looking at different ways of presentation of fractions and their concepts. I am Maria DeLucia from Middlesex County College, and my colleague Dr. Frank Bardella will be here from Hunter College. Our goal this afternoon will be to look at different ways of approaching the basic underlying concepts of fractions. Our objective will be to be using linear models to develop the conceptual knowledge of fractions, develop fractions as numbers, represent fractions on a number line, operations with fractions, and develop a connection between words and symbols. We will be doing this through showing you some videos and looking at some tasks as based on the Common Core standards to look at the approaches in which we can teach students to understand fractions.
The model we're going to use is what we call the M4 model, and it's 4 branches of getting children to learn mathematics. The mathematics done at each of the 4 branches is basically the same mathematics, except it's done in a different style. For example, the first level is the kinesthetic level, which many people call the concrete, where children basically interact with the materials and the teacher, but there's nothing written. There's no paper and pencil. The second one, which is relatively new and something we have been fostering for years, has been this idea of involving language. That is, before we get to the symbolism, we start having children write the language or the words that they're saying. For example, many children go through fractions and never write the word fourth. We will talk about this more in some of the materials we will show you later, is the connecting, which now connects the kinesthetic and the work done in the kinesthetic and the work done in the language to the symbolic. And finally, the last one is obviously the symbolic. And that's where we want kids to get to. However, you have to remember that the symbolic is really a recording device. And if you deem it as a recording device, students see that the mathematics is happening elsewhere. In other words, at the kinesthetic, language, or connecting level.
One of the important parts with the language today is the Common Core is talking a lot about students being able to record and to write. So that language piece becomes a very, very important piece today, especially with the Common Core. If we look at some of the research behind the learning theory of fractions, we will see from NAEP that reports show that fractions are exceedingly difficult for children to master. If we look at some of the reports of how our children are doing in the schools, they do well until the 4th grade. Why until the 4th grade? Because if we look at it, that's where fractions are being introduced. Students, if we look at it, are frequently unable to remember prior experiences about fractions covered in lower grade levels. They learn a process without really understanding what the fractions concepts are and how to utilize the rules. They just mush all the rules together without really understanding them. So if we look at different ways of being able to develop that conceptual understanding, students will have a better chance of remembering the rules and being successful. As we look at the statement from NCTM believes that students need to have a deep understanding of fractions and be able to use them competently in problem solving. Fractions are a basis of being able to do higher and advanced math. Research has shown that if students have a good understanding of fractions and decimals and proportional reasoning, they will be successful in being able to do algebra and advanced math. So if we look at developing those conceptual and fundamental understanding deeply, we're giving our students the ability to be successful in mathematics. If we look at the research done by the National Research Council on defining mathematics proficiency, we will see that they define it as conceptual understanding, procedural fluency, strategic competence, adaptive reasoning, and productive disposition. If we notice that the Common Core talks about conceptual understanding and procedural fluency. So prior to the Common Core, the National Research Council felt that these two concepts were very important in having our students become adaptive and proficient in mathematics. So in looking at that, we're basing our Common Core today on two of the proficiencies that were defined prior. So it is important that our students have this conceptual understanding and be able to use that understanding to solve problems and develop that fluency. If we look at the Common Core state standards mathematical practices and how they define that we should be developing the concepts and ideas of the students, they define that we should make sense of the problems and persevere in solving them. Students need to understand the problem before they can even determine how to solve the problem. So making sense of the problem is the utmost importance. Reason abstractly and quantitatively. Well, how do I abstractly understand what's happening here? Construct a viable argument and critique the reasoning of others. Model with mathematics. That is an utmost importance to model with mathematics. If you look at many of the tasks that the Common Core is asking, how students should solve it, they ask for models. They ask to construct an argument to satisfy the answer. Use the appropriate tools strategically. Attend to precision. Look for and make use of structure. That again is very important. How do I structure the solution? How do I come to that solution? Look for and express regularity in repeated reasoning. This afternoon we are going to look at mostly how to model with mathematics, look for the use of structure, how they tie together, how we can make sense of the problem, and lastly, how do we construct an argument that satisfies and makes sure that we have an understanding of what the problem means and how to solve that problem. Research has also shown that it is widely recognized there are at least two major issues in mathematics education of grades K to 8. It starts with fractions. Students really do not have a handle on fractions. They're used to working with whole numbers, with addition, subtraction, multiplication, and division. Now all of a sudden you're introducing a number that's a part of something. When you start to add fractions, you need common denominators. When you start to divide fractions, there are different rules again. So fractions start to where students do not really understand and cannot make the connections to whole numbers. And that becomes a problem. The second one is looking at the introduction of algebra. They start with the algebra looking for these unknowns, and now they're looking for how do I tie this all together. So, as I stated before, that our students do really well, and then all of a sudden the scores start to drop. Why? Because we've introduced a new concept, and that concept is a fraction. And how do I deal with that fraction? As it goes on, we start to talk about proportional reasoning, which is another fundamental to be able to succeed in mathematics. We will be doing another webinar on ratio and proportion, and that then starts to look at how we can develop the concepts for students to be able to succeed in higher mathematics in order to succeed in the study of algebra. Remember, having a good foundation in our numbers will help us in the foundation of algebra. What is algebra? Algebra starts to look at taking the generalization of our numerical properties and putting them together. So we need to overcome these obstacles of how do we teach fractions, and then how do we teach ratio and proportion, and how do we tie that into the teaching of algebra. I believe one of the biggest misconceptions that students have about fractions is that they can apply all of the rules that they have learned about whole numbers, how to add whole numbers, how to subtract whole numbers, to the rational numbers, and not realizing that we're talking about differences in quantities. We're talking about wholeness versus parts of. So this runs into a problem. Running into a problem of that I need to have a common denominator when I add and subtract fractions, but I do not need a common denominator when I multiply or divide fractions. Why is there a difference here? I don't have that difference when I add and subtract, multiply, or divide whole numbers. So it's the changing now of the rules and what applies to whole numbers versus what applies to my rational numbers, my fractions. Not having a full understanding of, or a conceptual understanding of the difference starts to, with the students running into the problems, and again, that begins the downfall of their ability to pursue problems with when do I add, when do I subtract, when do I multiply, when do I divide. So we're going to look at some ways of what we hope will be techniques in how to teach students to develop that understanding of fractions and tie some of it into what they have, their prior learning. And I think that's important, looking at prior learning and how some of that prior learning ties into my ability to do fractions. All right, now let's start to look at what the Common Core State Standards talks about fractions in the different grade levels. Let's start with grade 3. If we look at the first standard that they're talking about, it's talking about understanding a fraction 1 over b as a quantity formed by one part of a whole is partitioned into b equal parts, understanding a fraction a over b as a quantity formed by a parts of size 1 over b. Well, looking at how do I take a whole and divide it into 3 parts, and one part would be a third. If I take a third plus a third, I now have 2/3 of the whole. If I take a fraction and a whole and divide it into 4 parts, one piece would be 1/4. 2 pieces would be a fourth and a fourth, which would give me 2/4. So looking at how I can form the fractions of taking a whole and dividing it into equal parts. So that's the first understanding of fractions. It's talking about taking a whole and dividing it into equal parts, which they are now calling partitioning them. Partitioning a whole into equal parts. So how do we get students to understand that? How do we get students to understand I am now looking at taking a whole and dividing it, or partitioning it, as they're now calling it, into different pieces that will make up the whole. The second standard that we have in the Common Core on fractions in the 3rd grade is to understand that the fraction is a number, and that number can be represented on a number line. By looking at a diagram, we know that we teach students how to represent 1, 2, 3, 4, 5 on a number line, but now we're going to start asking them to start to represent 1/3, 1/2, 1/4 on a number line, giving them the understanding that a fraction is a number. The second part of that standard is that we're going to represent a fraction 1 over b on the number line in the interval from 0 to 1. So we're showing that it's going to be less than 1. It's equal parts. If I took the equal parts and lined them up, I would get to 1. But now I'm going to show that this fraction is a number between 0 and 1. So if we look at it, we're now going to be able to talk about ordering fractions, also looking at is a fraction closer to 0 or closer to 1, again giving it relative position of size. So we're looking at how do I now take these fractions, these equal pieces, and represent them on a number line. Again, giving the student the understanding that a fraction is a number and has a place on the number line. All right, if we look further at the standards, it's talking about representing a fraction AB on a number line by marking off A lengths 1 over B from 0, recognizing the resulting interval has a size AB and then its endpoint locates the number AB on the number line. Again, looking at if I have 1/2 plus 1/2, I would get a whole. If I have 1/3 and 1/3, I'm still getting a number that's less than 1, and I have 2/3. So looking again at placing numbers on a number line. The Common Core is looking at giving the students the notion that developing that idea that a fraction is a number, it is placed on a number line, and we're moving away from looking at circles and pies by having the students start to place these numbers on a number line.
So what we have then is with a linear model, the idea that half, given the same context, and that's really what children have trouble with, is that given the context in the example I gave before, that in some cases 1/2 will be smaller than 1/3. However, here, where they're all the same length, they're all equal to the same one in a sense. You have 1/2 being greater than 1/3, 1/3 being greater than 1/4, and 1/4 being greater than 1/6. And across each one, you see that 2/2 is a whole, 3/3 is 1, 4/4, and 6/6 is 1.
Next, we're going to show you a video that we created to help students model, to look at how to use comparison of fractions and the size of fractions. This video will demonstrate the use of modeling for mathematics, addressing one of the Common Core mathematical practices. So we're looking at this video to demonstrate modeling and helping students develop that conceptual understanding of the size of fractions.
In this video, what we're going to do is we're going to look at how to place fractions on a number line. Now, in front of us, we have a piece of a number line, and I'm going to label it from 0 to 1. And what we're going to do is we're going to work on how we can place fractions on this number line. And the fractions we will use for this will be thirds. So let's look at 1/3. 1/3 goes from 0 to this point right here. So the distance from 0 to this point, we can say, is 1/3. Now let's look at 2/3. 2/3, well, first of all, 1/3 goes from 0 to the point we just did. 2/3 will go from 0 to this point. So now we have 2/3. So from 0 to this point is 1/3. From 0 to this point, this whole distance here, is 2/3. And now let's look at 0 to 1. And 0 to 1 is going to be 1, 2, 3/3. So from 0 to 1 is the same as 1, 2, 3/3. It's the distance from 0 to 1 is actually 3/3. So in placing thirds on the number line, from 0 to this first mark is 1/3. We can show that. From 0 to the second mark is 2/3. And finally, from 0 to 1, or the third mark, is 3/3. And if you will notice, when we do that, the number line now is broken into 1, 2, 3 equal parts. Each of those is 1/3.
In the video, you will notice how the standards were addressed. We took the interval from 0 to 1, divided it into thirds, demonstrated how you can take 1/3, put it at the endpoint from 0 to a mark, then take another third, matching it up and getting 2/3, and again taking the last third, and you're showing that you're partitioning the interval into thirds, demonstrating how you can get 2/3. That would be addressing it as A over B of equal parts. So this video is now demonstrating how I can model taking my fraction bricks and dividing the interval into equal parts, placing those parts on the number line in the interval from 0 to 1. So I'm addressing the standards. I'm using mathematical models to develop that conceptual understanding of numbers as fractions on a number line. So this video will give the students the visualization of what those standards are and how to address those standards. As seen in the video, we have taken the fractions, the interval from 0 to 1, and partitioned it as according to the standards. So now let's look at this picture of fraction bricks where we have partitioned the equal unit into halves, thirds, fourths, and sixths. And you can see that partitioning it into equal units, in partitioning it as the unit into different segments. And if we draw a line down, you can see the comparison, which now gives the students the ability to order the fractions from the smallest to the greatest, or the greatest to the smallest, depending upon which way you want to look at it. We can see that 1/6 is less than 1/4, 1/4 is less than 1/3, 1/3 is less than 1/2, and so on. So we're looking at giving the students a model, a visualization on how to look at comparing fractions, and by partitioning it in an interval from 0 to 1. And in looking at these pieces, as was demonstrated in the video, we can take these pieces and align them in the interval, showing that 3 1/3 will give me 1, 4 1/4 will give me 1, 6 1/6 will give me 1, 2 1/2 will give me 1. So in aligning it and then using it as a comparison. We just showed you on the slide how to use the comparison of the strips and partitioning an interval from 0 to 1 by halves, thirds, fourths, sixths, and using comparison. We're now going to show you a video using manipulatives so that students can do the comparison using manipulatives.
What we're going to do now is look at the comparison of fractions. Here I have 1/3 and 1/2. Now it is obvious using the fraction bricks that 1/2 is larger than 1/3. And we could say that's all we have to do in comparing fractions. But what we're going to do is a little bit more, and this will help us down the road when we're just dealing with fraction symbols. What we are going to do is look at other fractions and have them help us compare our original fractions. For example, I know that 2/6 is equal to 1/3. I also know that 3/6 is equal to 1/2. So now, instead of just directly comparing 1/3 and 1/2, I can compare them using sixths. Since 3/6 is equal to 1/2 and 2/6 is equal to 1/3, I have another way of saying that 1/2 is larger than 1/3 because the 3/6 are larger than 2/6. So, two ways of comparing. Number one, actually comparing the fractions themselves, and in this case we see that 1/2 is greater than 1/3. Or using sixths, since sixths are used with both halves and thirds, and showing that 3/6 is greater than 2/6, so therefore 1/2 is greater than 1/3.
As seen in the video, you will notice that students can use the manipulatives, the bricks, for comparison of fractions. This allows the students to come up with a viable argument as one of the mathematical principles stated in the Common Core by allowing students to demonstrate the ability of showing that 1/2 is greater than 1/3. Also noted in the video is that the students are now using the bricks to do some renaming to find equivalent fractions such that 1/2 is equal to 3/6, 1/3 is equal to 2/6, and again using the comparison that 3/6 would be greater than 2/6. This now helps us down the road in finding equivalent fractions when we start to come to the addition and subtraction of fractions and being able to find a common denominator. So this all ties very nicely into being able to use the bricks and the manipulatives to rename fractions and for comparison. We're going to look at another video, and the video is very similar to the one we just saw, except in this video we're now going to introduce the language. In the beginning we said that we were looking at an M4 model where we were talking about the kinesthetic, which is moving of the manipulatives, and the language. The language part becomes a very important piece in, again, going back to the Common Core and stating that, students should be able to give a viable argument, talk about it, rationalize it, and be able to speak about it. So in this video, we're now going to look at what we've just done, but introduce a new piece, a new concept.
We are now going to take 1/2 and 1/3 again, and we're going to compare them. Except this time, we're going to use the words involved in the comparison. So we can see from our comparison here that 1/2 is larger or greater than 1/3. So we say that 1/2 is greater than 1/3. Now, when we have the bricks, that's easy to do. But let's look at the way we did it in the first video on comparison, where we looked at 1/3 and showed that that was equal to 2/6. And then we looked at 1/2 and we showed that that was equal to 3/6. So now let's look at our writing. Instead of 1/2, we now have 3/6. Is greater than 2/6. So now we have again the idea that 1/2 is greater than 1/3 using the bricks, or the idea that since 1/2 is equal to 3/6, that's the first thought, and 1/3 is equal to 2/6, that's the second thought. 3/6 is greater than 2/6, that's the third thought, and therefore 1/2 is going to be greater than 1/3, and that's the conclusion. So what we have here then is we have 1/2 is greater than 1/3, 3/6 is greater than 2/6 because 1/2 is equal to 3/6 and 1/3 is equal to 2/6. And we can say again that 1/2 is greater than 1/3.
Now let's look at a task that can be used as a form of formative assessment to determine the student's underlying conceptual understanding of being able to partition fractions in the interval from 0 to 1, order and compare fractions. If we look at this task, the task is asking us to locate fractions that are less than 1 on a number line, locate fractions greater than 1 on the number line, closest to 1/2, find 1, find 2/3, which is closer to 1. So let's think about what we just showed you in the video, what we talked about with the fraction bars and being able to partition into equal lengths of the interval from 0 to 1 using halves, thirds, fourths, and sixths. So in looking at that, how would we get the student to either with manipulatives or drawing a diagram? Because remember, the Common Core says modeling with mathematics, using appropriate tools. Tools could be a diagram, it could be the manipulatives, looking and making use of the structure. How do we structure this problem to be able to partition it into different equal equivalent lengths, thirds, halves, fourths, and sixths. And again, reason abstractly to look at these pieces and trying to determine which would be closer to 0, which would be closer to 1/2, which would be closer to 1. So let's look at this, let's think about it, and let's try to determine how the students would be able to answer this question. All right, now let's look at the solution. This is one of many possible solutions, or one of the many ways that a student can approach this problem. So if we look at the solution here, you can take what we've talked about in partitioning again the interval from 0 to 1 into equal unit lengths. So if you look at, they've partitioned the first number interval from 0 to 1 by using fourths, and you've got the first one as being labeled 1/4, 2/4, 3/4, 4/4, which is 1. Looking at the second interval and using thirds, and looking at that and saying, okay, the first mark is 1/3. If I move over, there's 2/3. So now I have the position of 2/3 on a number line. And now when you're looking at which is closer to 1/2, I've taken my interval and I've subdivided it into partitioning it into two equal lengths, being 1/2. And now looking down, and again, as we had seen before, what we showed you, our vision of the fraction bricks, and looking at the partitioning and drawing a line down from 1/3, from 1/4 to the bottom, and using the numbers at the bottom as comparison, we can look to see that 1/3 would be less than 1/2, 1/4 is less than 1/3, which is then less than 1/2. So when you're looking at this, and again ordering it, it's giving the students the ability to visualize and use these mathematical models to justify their answer. This is an important part when you start to look at how students are beginning to talk about equal lengths, but the most important thing is they're taking intervals of a whole from 0 to 1 that are of the same length. We're not asking them to subdivide units of different lengths that's all the same, because remember, when you start looking at fractions, it's all relative. A quarter of a student body may be more than half of a candy bar, so it's all relative when you start looking at the comparison of fractions being of equal length, not of different sizes. So that is an important piece when students start talking about, just because I talk about the quarter of something doesn't mean that that quarter is always less than a half. So the important piece here is that when I'm subdividing a unit of equal length. Now if we move on to grade 4 on the Common Core standards, we see that they are talking about now extending the understanding of fractions in partitioning and ordering by looking at the fractions with different numerators and different denominators and creating common denominators is what we did before when we looked and we saw the video when we looked at 1/2 as being 3/6, 1/3 as being 2/6, and now being able to compare those fractions. But now they start to introduce the greater than, less than, and equal symbols. And if you look at the standard very carefully, it says justify your conclusion by using visual fractional models. Again, it could be with manipulatives, it could be with drawings and diagrams. So they're extending, but now they're introducing greater than, less than, equal to. So again, if we get the students to understand the partitioning into equal lengths, and as it states here, we're looking at using the fractions of referring to the same whole of equal lengths and being able to compare, because again, it's all relative. Again, looking at that 1/4 of something may be more than 1/2 of something if it's not of the same whole. So we're extending it, and we're now looking again to use these models, and the models that we're using is making this connection, as we said before in our M4 model. We have the kinesthetics, we have the language, and now we're trying to make a connection between those models and these fractions. Let's now look at another task. This task talks about ordering fractions from the smallest to the largest. But let's note that this task goes beyond just using the unit fractions. We notice that we're talking about 3/8, 1/3, 5/9, 2/5. Not only do we have different denominators, we have different numerators. We're not talking about 1/3 versus 1/4 versus 1/6. We're not using the unit fractions. We're now going beyond that. So if we read this further, it states, to explain your reasoning, use models. Let's take a minute and think about how the student would solve this or could solve this using a diagram or using manipulatives. So let's just take a moment and think about how we would solve this problem. Okay, if we look at a possible way of solving this problem, if we were to take our fraction bricks of equal length of an equal unit and take one of them and divide it into eighths and then mark off 3/8, take a second one and subdivide it and partition it into thirds, mark off 1/3, take a third, partition it into ninths, count and mark off 5/9, take another one and partition it into fifths, mark off 2/5, and as we did before, taking a vertical line and drawing it to the bottom, and again drawing a number line at the bottom, taking those numbers and rewriting them at the bottom on the number line, we can then see how we can order the fractions and which would be greater and which would be less. So it's giving the students the ability to use their models and then looking at those models, analyze, and be able to reason and explain which would be larger and which would be smaller, which is greater than, which is less than, and if any of them are equal. So again, we're going back to the visual models to be able to explain and to reason the solution. So again, it's going back to what we've said, that kinesthetic part of being able to manipulate and internalize all of these rules so that they're just not saying, okay, because 8 is larger, going back to, again, looking at whole numbers, because 8 is larger, 3/8 has to be greater than 5/9, or 5/9 is greater than 3/8 because 9 is greater than 8. So again, looking at how this helps the student to be able to visualize and understand the comparison and the ordering of fractions, greater than, less than.
Denominator.
And one of the things also that occurs is that since if you see all those fractions down at the bottom, they are the recording of what's going on. The students are constantly being reinforced with going back to the models. So there are two ways of doing that. Number one is obviously giving them the models to work with, which should be an ongoing thing. Or number two, having them actually do more diagrams. Because when they get into a testing situation, they will not be able to bring the models into the testing situation. However, if we get them to draw diagrams and they feel comfortable with drawing simple diagrams, when they get into a situation where they do not understand what's going on or just feel confused by what's going on, they can draw a diagram and hopefully that'll help them.
As we move on with the Common Core standards in grade 4 for fractions, you will see that the next one has to do with the understanding of addition and subtraction of fractions as joining and separate pieces, again referring to the same whole. So now we're talking about addition as the joining and subtraction as the separation. So we're looking at having the students, again, use mathematical models. And in looking at these models, they're going to start first with a common denominator and then eventually move on to unlike denominators of the addition and subtraction. What we've done prior, when you're looking at starting to look at the unlike denominators, is using those equivalent fractions. So those models keep coming back as a building block of having the students realize and state, well, I remember this, I can do this by using my models and rename 1/2 as being 3/6, 1/3 as being 2/6, and starting to look at being able to join and separate these fractions through addition and subtraction. On the previous standard, it talked about addition and subtraction of fractions and joining and separating and referring to the whole. Now if we go further into the standards, we see that They are now talking about addition and subtraction of mixed numbers with like denominators. And again, talking about being able to replace fractions with equivalent fractions. So what we'd like to do now is show you a set of videos, and these videos refer to the subtraction of mixed numbers, which seems to be a little bit more of a difficult concept than the addition of mixed numbers. So we will show you a set of videos and have you again look at how we do this, again using fraction bars as the manipulatives to demonstrate the concept of what we are doing when we are subtraction. So it's an important part that students understand what you mean when you talk about subtraction as being a taking and away. So we will proceed with showing you these videos.
We're talking about subtracting mixed numbers. And we're going to start with the mixed number 3 1/4. Now from 3 1/4, we want to subtract 1 2/4. Now you have to remember that the 1 2/4 is somewhere in the 3 1/4. It is not another quantity someplace else. So we have to find 1 2/4 in 3 1/4. So let's start the subtraction. We want to subtract 1 2/4. That means we want to subtract 2/4. But we only have 1/4. But what we can do is we can trade one of our ones for 4/4. So we trade one of our ones for 1, 2, 3, 4/4, and we put the fourths with the other fourth from the original part of the problem. Now we wanted to subtract 2/4. We now have 1, 2, 3, 4, 5/4. We can now subtract 2/4. That leaves us with 1, 2, 3/4. And in the original problem, we wanted to subtract 1 2/4, so we can now subtract 1. And that leaves us with 1 1, 2, 3/4. So in subtracting 3 1/4 minus 1 2/4, our answer is 1 1, 2, 3/4.
Now, if you'll notice in that video, the number that was not shown was 1 2/4. That's where the confusion comes from children, because they start to subtract 2/4 from 1/4. You can call it the path of least resistance. So in the next video, we're going to show how we start to break into this idea of we have to show the 1 2/4, but we do it in a special. We show it as a special number. Again, not as a quantity someplace else.
The important part of all of this, and I guess this is what we're trying to demonstrate, is that the Common Core talks about modeling. And the modeling with fractions becomes very, very important. That kinesthetic is that ability for them to see and internalize what they're doing. Because just giving them a rule, they have a rule, but now we're trying to develop that conceptual understanding of why, renaming fractions, common denominators, which is larger, placing them on a number line, because a common mistake, and I see it when I teach my developmental courses at the college, students do not, they take as I stated in the beginning, to apply the concepts for whole numbers, what they did in whole numbers. Since 3 is larger than 2, then 1/3 should be larger than a half. So it's that common error, those misconceptions, and that ability to look at how and then why we need a common denominator. How do you put a half plus a third together? Well, I cannot add them together, but if I use these models, I can do it. So the important part of developing this sense of modeling with them and using these bricks becomes a very important aspect for them to develop that conceptual understanding and that procedural fluency.
Because with the bricks, and let's just jump to adding with unlike denominators for a second. With the bricks, you have an overriding concept in addition. You can only add things that are the same. However, children don't have that problem when they add 1/2 and 1/3. They just add them, as some of you may have already seen. But with the bricks, you can't do that. With models, you cannot just say 1/2 added to 1/3 or attached to 1/3 is something. It's not. It's still 1/2 and 1/3. So they start to get special with the concept that you can only add like things. So here we now go to the language portion of subtracting mixed numbers with trading.
We're talking about subtracting mixed numbers. So let's look at the mixed number 3 and 1/4. And let's record that in words. 3 and 1/4. Now from 3 and 1/4, we want to subtract 1 and 2/4. So let's record that. So we want to subtract 1 and 2/4. Now remember that the 1 and 2/4 is not a quantity someplace else. It's somewhere in our 3 and 1/4. So let's do the subtraction. I want to subtract 2/4, but I only have 1/4. But what I can do is I can trade one of my 1s for 4/4. And let's record what we've done. So we've traded one of our 1s, so that leaves us with 2 1s. And we've traded that 1 in for 4/4. So we trade our 1 in, and we put our 4ths with the 4th from the original problem. And that gives us a total of 5/4. We wanted to subtract 2/4. We can now subtract 2/4 because we have 1, 2, 3, 4, 5/4. So let's subtract 2/4. That leaves us with 3/4, and we record that. In the original problem also, we wanted to subtract 1. So let's subtract 1 from our 1s, and that leaves us with 1, 1, and let's record that. So our answer now is 1 and 1, 2, 3/4. So when we subtract 3 and 1/4 minus 1 and 2/4, our answer is 1 and 1, 2, 3/4. And the reason we can do this is we traded one of our 1s for 4/4.
And I want you to notice that in that video, every time I related something about the quantity that we had, I pointed to the models because that's where we want to concentrate. When I talked about the number that we were subtracting, I pointed to the numbers in red, and that's why we wrote them in red, because they're embedded someplace in that 3 1/4. And so as a result, we continue that theme with the students, that the work is happening on the mat, and the paper and pencil is the recording device. So now let's go to the third level, which now talks about, and this is the level that a lot of people jump to as soon as they use the manipulatives or the physical models. They jump to what we call our connecting model, which connects, for us, the kinesthetic or the modeling and the language with the symbolic.
We are talking about subtracting mixed numbers. So let's look at the mixed number 3 1/4. And let's record that in fraction symbols. So we have 3 1/4. Now from 3 1/4, we want to subtract 1 2/4. We want to subtract 1 2/4. Now remember that the 1 2/4 is not another quantity someplace else. It is in 3 1/4. So let's do the subtraction. The first thing I want to do is I want to subtract 2/4. But I only have 1/4. But what I can do is I can trade one of my 1s for 4/4. And let's record that. I trade one of my 1s for 4/4. That means I have 2 1s left. And I have 4/4. So I trade my 1 for 4/4, and I put my 4/4 with the other 4th from the original problem. I now have a total of 1, 2, 3, 4, 5/4, and I record that. Now, I wanted to subtract 2/4. I can now do that because I have 5/4. So 5/4 minus 2/4 leaves 3/4, and I record that. In the original problem, I also wanted to subtract 1, so I can do that now. That leaves me with 1 1, and I record that. So my answer is 1 1 2 3/4. So when I subtract 3 1/4 minus 1 2/4, my answer is 1 1 2 3/4. 1 3/4. And the reason I can do that is I traded in one of my 1s for 4/4.
Now the last video is the system, which is the symbolic. But what I want you to listen to is to listen more than watch, because I think you know what's going to happen in the symbolic system. I want you to listen to the words and the language that I use, because it is the same language that we've used through the last 3 videos. So there's no change of language. The students are used to the language, they understand it, they know what should happen, And hopefully what we're building in their mind's eye is a view of the fraction pieces as they now use it in the symbolic level.
We're talking about subtracting mixed numerals. So let's look at the mixed numeral 3 and 1/4. And from 3 and 1/4, we want to subtract 1 and 2/4. Now remember that the 1 and 2/4 is somewhere in 3 and 1/4. It is not a quantity someplace else. So let's do the subtraction. The first thing I want to do is I want to subtract 2/4. But I can't because I only have 1/4. But what I can do is I can trade in one of my ones, which will leave me with 2 ones, and I can trade that 1 in for 4/4. Now I have a total of 5/4. I wanted to subtract 2/4. Now I can subtract 2/4 because I have 5/4. 5/4 minus 2/4 gives me 3/4. Also in the problem, I wanted to subtract 1. I can do that now. I have 2 ones minus the 1 gives me 1. So my answer is 1 and 3/4. So when we subtract 3 and 1/4 minus 1 and 2/4, our answer is 1 and 3/4. And the reason we can do this is because we trade one of our ones for 4/4.
In the videos, we demonstrated how to use the manipulatives to demonstrate the process of subtraction. So let's now move on to a task which can now demonstrate using the manipulatives of a real-world problem, a practical application. The task is Alfredo picked 3 2/5 pounds of peaches from a tree in his backyard. He gave 1 4/5 pounds to his neighbor Madeline. How many pounds of peaches does Alfredo have left? So again, in looking at what we did in the video, remember that that 1 4/5 is contained in the 3 2/5. So how would the student, let's take a moment and think, how would the student show, using a manipulative or a diagram, how to solve that problem? Okay, after thinking about it, let's talk about if we did exactly what we did in the video. Take 3 unit strips, 2/5 pieces. Now talk about how we can take 1 4/5 from that. Again, we would have to rename because we cannot take 4/5 from 2/5. So again, it's now taking what we demonstrated in the video and applying it to this task. So students could either explain it verbally, they could use manipulatives, or they can draw a diagram. So there are different processes based on a student's ability to solve the problem. So again, let's think about what the student has learned by using this as a formative assessment to determine whether or not they really have a fully understanding basis of how to subtract mixed numbers. Okay, In grade 5, dealing with fractions, they now introduce the concepts of multiplication and division. In grade 3, you were just talking about what is a fraction, how to compare fractions, how to partition a unit into fractional pieces. In grade 4, you're introducing addition and subtraction. Now in grade 5, you're introducing multiplication and division. These are the two operations that I think create more of a misconception if they're trying to relate back to their rules for whole numbers. If I add two whole numbers, I get a number that's larger. If I subtract, I will get something that's smaller. Now we're dealing with multiplication of fractions. I can multiply two fractions and I will get an answer that could be smaller. So here again, it's looking at, trying to correct those misconceptions of that everything that works with whole numbers does not work with fractions. An important part of the standard is looking at the interpretation, interpreting your answer. What does your answer mean?
What happens here is their lack of understanding of what multiplication is for whole numbers really comes out. Because 3, and they give an answer of 6. And they really don't understand that you're talking about a set of 3 2 times. So you have one thing that is the set, and the other thing is how many times do I have that set? And so when they come to explain fractions, how do you explain a half of a third? Do I have a third? All they do is they multiply across the top, multiply across the bottom, and hope for the best. So let's look at an example of how we can get around that.
What we're going to do is we're going to look at the fraction 1/3. And we're going to take half of 1/3. In a sense, what we're going to do is we're going to multiply 1/3 by a half. So it's 1/2 of 1/3. The question is, what is 1/2 of 1/3? Well, I could try fourths, but they don't fit, okay? Because we're looking for a half, we're looking for two pieces that will equal 1/3. When we use sixths, we find our pieces. Here we have two equal pieces that are equal to 1/3. So we can say that a half of 1/3 is 1/6. So a half of 1/3 is 1/6. Now, in the rest of the videos dealing with this problem, we are going to see how to write that in words and then in symbols.
So here's the language part of multiplying fractions.
That's it.
We're going to look at our 1/3 again, and we're going to again ask the question, what is 1/2 of 1/3? Well, as I tried before, I could see fourths, but fourths don't make a half of a third. When we try sixths, we now see that a half of a third is actually 1/6. So I can take this one away, and now we see that 1/2 of a third is actually 1/6. So 1/2 of 1/3 is 1/6.
happens when you use the materials, the models, is that age-old misconception that they come to you with about multiplication is when I multiply two numbers, I get a bigger number. And that is because, as I said before, they don't understand what multiplication is. It's the taking of a number of pieces. And so as a result, here right before their eyes, they're seeing that the multiplication of a half and a third actually comes out to be smaller than either a half or a third.
Another one of the standards for grade 5 is the interpretation of division of a whole number by a unit fraction. Compute such a quotient. So we're looking at division of fractions, which again is one of the, I believe, other than finding the common denominator, very hard concept for students to understand. Here I am dividing two numbers, a whole number by a fraction, and my answer will be a number that's greater. And usually in division of whole numbers, I get an answer that's smaller. So now we're looking at division of fractions. You know, they've learned the rule invert and multiply, but why am I doing it? What does my answer mean? I think an important part here is the interpretation of the answer. What does the answer mean? If I take 4 and divide it by 1/5, I'm asking how many 1/5s there are in 4. That interpretation and what does the question mean is a very important part of the relationship of division and multiplication. So again, in the standard, it's saying use visual fractional models to show the quotient. So again, we're going back to that modeling, that mathematical modeling. So here we are going to, again, show you another video, which will now demonstrate how to do the division of fractions.
In this video, we're going to take a look at a whole number, in this case 2. And what we want to do is we want to find out how many thirds we have. Now in mathematics, another way of saying this is we want to take 2 and divide it by 1/3. That means we want to find out how many 1/3s are in 2. Well, let's look at our first unit. In our first unit, we have 3/3. And in our second unit, or our second one, we have another 3/3. So we know now that when we have 2 ones, or 2 units, we will have 1, 2, 3, 4, 5, 6 thirds. So in 2 units, we have 6 thirds. So we can say that 2 divided by 1/3 is 6 thirds.
In the last video, it was demonstrated how to take 2 and divide it by 1/3. Again, it goes back to the interpretation. The interpretation was how many 1/3s are there in 2? So again, looking at how to take each unit and rewrite it in terms of thirds. There are 3/3 in each unit. So in 2 units, there are 6 thirds. So taking 2 and dividing it by 1/3 gave us an answer of 6 1/3s in 2. So now let's look at a task that kind of pulls that concept together. And if we look at the task, it states Avery and Megan are cutting paper to make origami stars. They need 1/5 of a sheet of paper in order to make each star. If they have 6 sheets of paper, how many stars can they make? Explain your work and draw a picture to support your reasoning. So again, it goes back to the interpretation. What is the problem asking me? So let's take a moment and think about that. What is the actual question that I am asked to solve here? So if we look at this question, we're asked to, it states that each star is 1/5 of a sheet of paper. So basically, I'm asked what the question is asking in terms of mathematics, or changing it from a verbal problem to a symbolic problem in terms of numbers. It's asking, or being written in mathematically, 6 divided by 1/5, because I'm asking how many 1/5s are there in 6. So if we go back to the video, I would take each unit and divide it into fifths. There are 5/5 in each unit. So if there are 5/5 in each unit, there are 30/5. So I would be able to make 30 stars. If the student was to draw that with a model, they would use the model that was demonstrated in the video, and in looking at it, I would take each of those units, divide it into 5/5 per unit, multiplying it or counting them, I would end up with 30/5. 30/5 tells me I can therefore make 30 stars. I'd like to thank you for attending the webinar this afternoon. Dr. Gardella and myself were delighted that you could be with us. We hope that we've given you something to think about and how to address the Common Core using visual models. If you have any questions or comments, please feel free to email Frank at fgardella@comcast.net, or email me, Maria DeLucia, at comcast.net. We would be delighted to hear from you. Any comments or questions that you have, we would be very happy to answer them. Thank you again for attending.